All right, let's do this example here. Okay, so example 6. So we're given this matrix T. Okay, now let's first find the adjoint of this. Okay, so now to find the adjoint, we're just going to fill this up with the determinants when we go row by row, entry by entry. So this is going to, if we do 1, this is going to give us what? 1, 0, negative 1. So we're going to put the determinant of 1, negative 1, 0, 1. And then we go to the next one. That's going to give us, now again, remember, we're going to be alternating signs as we go across. Positive, negative, positive, because again, as we add the indices, we're going to get positive, negative numbers. So it's going to be positive, negative, positive, negative, positive, all the way through, okay? So then the next one's going to be negative, so that's going to be negative, and it's going to be what? It's going to be 2, negative 1, 1, 1. 2, negative 1, 1, 1. And then the next one in the row is going to be positive, so it's going to be, then it's going to be 2, 1, 1, 0. 2, 1, 1, 0. So that's the first row. Now let's do the next row. So this is going to be again negative, and it's going to be 0, 4, 0, 1. Right? Oh, I made a mistake. Hold on. I made the classical mistake. I forgot. Remember the adjoint, the indices are reversed. So this should be, it's JI, not IJ. So we're going to go down the columns. So this is 0, 4, 1. And the other one, so we're going to switch those. So they're switched along the diagonal. So that one. So I switched these. This one is going to go here. Which is going to be 2, 1, 1, 0. So this is going to be 1, 1, 2, 1, 3, 1. So 1, 1, 2, 1, 3, 1. So we're going to go down the columns. So going across the rows is the same as going down the columns of this one. So for this one, we get this one. For this one, we get this one. For this one, we get 0, 4, 1, negative 1. 0, 4, 1, negative 1. All right, so far so good. Sorry about the mix-up. Okay, so now we're going to go down this column here, which is going to give us this row. So if we go here, that's going to give us our 2, negative 1, 1, 1, which we already have. And then we're going to go down to this one. This one's going to give us 1, 4, 1, 1. And then if we go to the next one, that's going to give us which one? That's going to give us 1, 4, 2, negative 1. Oh, hold on. Wrong one. Over here. 1, 4, 2, negative 1. And now let's do the last column, which is going to give us the last row. So the 4 here already gives us these two, so we already have that one. So let's do this one. This one is going to give us 1, 0, 1, 0. And then finally, the last one's going to give us 1, 0, 2, 1. Okay, now let me double check. I think that's correct. All right, cool. So all of these are correct. Now just verify the signs. Now remember, the signs alternate. So it's going to be positive, negative, positive, negative, positive, negative, positive, negative, positive. Okay, so you just want to make sure that you've got the negatives where they should be. Now, all we have to do is simplify this. So let's simplify this matrix. Okay, oops, should be straight lines. There we go. So now we have the matrix of these cofactors, and so now we're just going to simplify them. So this is going to give us what? This is going to be 1 minus negative 1, which is 2, right? Hold on a second. Oh, I'm reading it wrong. Sorry. It's 1 minus 0 times negative 1, which is 0. So this is just going to be 1. Oh, this is going to be 0, right? Because we got this row of zeros, so, or column of zeros. So it's going to be 0. So that's going to be 0. And then here we've got 0 minus 4, so negative 4. And then here we've got 2 minus a negative 1, which is going to be positive 1. So 2 plus 1 is 3. Or negative 3 because of the negative. And then of course this one's going to be 1 minus 4, which is negative 3. This is going to be negative 1 minus 8, which is 7, which is going to give us a negative 7. Okay, so far so good. Oh, hold on a second. Let's do that one more time. Negative 1 minus 8. Oh, that should be negative 9, so it's going to be positive 9. That should be a positive 9. Sorry. Okay, so let's do this one. So this is going to be 0 minus 1. So that's going to give us negative 1. Again, this is going to give us 0 because we've got a column of 0. So that's going to be 0. And then here we've got 1 minus 0, which is 1. So that should be our matrix. So let me double check here. So we got 1, 0, negative 4. Okay, okay, looks good. Okay, now we're going to take the product with t. Okay, so now we're going to take the product with t. Okay, so what we'll do is we'll take 1, 0, negative 4, negative 3, 9, negative 1, 0, 1, times 1, 0, 4, 2, 1, negative 1, 1, 0, 1. And so now, if we multiply these together, we're going to get the determinant of t times I. Right? So this is going to give us the determinant of t from the theorem, this is going to give us the determinant of t times I. Okay, now if we multiply this, what do we get? Well, we get a diagonal matrix, right? And in this case here, if we go across the row, or excuse me, yeah, across the row down here, we get 1 times 1 is 1, 0 times 2 is 0, and we get negative 4 times 1 is negative 4. So we get 1 plus negative 4, which is negative 3. And so what we're going to end up getting is this. You can verify this. Is we're going to get that matrix. So now, guess what? The inverse of t is going to be equal to what? Now we can apply the formula. It's going to be 1 over what? 1 over the determinant of t, which now we know is going to be negative 3 because of we can see that in the diagonals. So it's going to be 1 over the determinant of t times the adjoint of t. Oh, excuse me. And so now we've got the adjoint and we've got t, which is negative 3, right? So we can just put in negative 3 here. And so now all we're going to do is we're going to multiply through by negative 1/3. And so if we do that, guess what? Our matrix, our inverse matrix for t is going to be what? It's going to be 1/3, or excuse me, negative 1/3, 0, 4/3, and then it's going to be 1, 1, negative 3, 1/3, 0, negative 1/3. Let me check. So negative 1/3, 0. Yep, that's correct. And so now that's the inverse. All right. Now, the formula from this subsection, yeah. Now, the formulas that were used from this subsection that we've gone are often used for by hand calculation and are sometimes useful with special types of matrices. We've seen some of those. However, for generic matrices, they are not the best choice because they require more arithmetic than, for example, the Gauss-Jordan method. So, just keep that in mind. Other than that, have a great day. See you next time.